Sonia, for the very, very kind introduction and the kind of invitation. Dear colleagues, dear students, thank you for coming. Salam. And yeah, let's dive into this talk. I have more than 100 slides, but we will not manage to talk about 100 slides. But I will jump around a little bit. The slides are mainly also for backup questions and discussions that we hopefully can have. Right. So we'll before we move into the topics, I want to mention that all of the work that you will see today is work with other people. It's always ideas that come out of collaboration, talking to other people, exchanging ideas, helping each other learn new methods, etc., etc. So science is collaborative, and you see this from all the names here. And there's actually more people, but this slide had to end somewhere. And I want to split the talk into three parts, a little bit, as Omnia was saying, to make it easier to comprehend, but also to see that there's different aspects in it. The first one is eye tracking. So we'll talk about eye tracking as a methodology. Then eye tracking, so it's eye tracking as a mirror of bilingual. So we'll talk about bilingualism. Bilingualism has a lot of aspects. For me, it's mostly heritage language bilingualism. So we'll talk about bilingualism, and we'll talk about language processing. So that's the methodological bit, that's the psycholinguistics, and then certain phenomena that we put and investigate in here. And yeah, following the structure, we'll start with eye tracking. And we already had a question about different setups of eye tracking that exist out there. A very common setup of eye tracking looks like this on the left or on the right. So you have a participant sitting sitting, and the head is resting on a headrest, and usually a bit fixated, so they don't move the head too much. This can be without glasses or with glasses. Both are usually fine as long as the glasses don't reflect too much. Then they're generally looking at a screen where we show them images or text. Here on the left, we see actually the calibration image. So to make sure that the camera finds the pupil in the middle of the eye, in the center of the eye. And to make sure that everything is standing kind of in the center of the screen. And here on the right, it's kind of within the experiment already, so the person is reading some kind of text. And what is very kind of striking is that below the screen, there is something that usually isn't there, which is the eye tracker, which is here, this is kind of one of the larger models. It has a camera on the left, an infrared camera, and it has an infrared light sensor sort of that sends out the light and also measures where the light comes back. And because the eyes, I mean, we don't have to go back too much of the details, but basically what happens is that the face and the eyes reflect, especially the pupil reflects the infrared light differently than the rest of the face, of course. And this helps the underlying algorithm behind the eye tracking camera to calibrate where on the screen, to find out and know where on the screen the person is looking. And this principle cannot just be used with infrared light. And with infrared light and infrared cameras, high-end eye trackers, it's usually very, very accurate on a millimeter level, so that we can know which of the letters, for example, in the text the person is looking at, which can be very useful in some studies. But there's also studies where we just show maybe 2 or 3 pictures on the screen and want to know which of the pictures a person is looking at. And this is the kind of study that I will be talking about more. So we will not be talking about eye tracking during reading in the talk. Of course, in a discussion, we can do that. And to kind of open up the eye tracking part, I want to talk about online webcam-based eye tracking for a few minutes. And give some reasons, first of all, why it could be good and useful to do online webcam-based eye tracking. And for many researchers in linguistics, this question became relevant in the pandemic because suddenly the labs had to be closed. People couldn't come to the university, to the lab anymore, but we still wanted to do studies. And one of the ways to do these kind of eye tracking studies was to have people do them at home with their own laptop, with their own webcam. Another benefit of having webcam-based eye tracking is that we can test non-weird populations. So thinking about, so weird means Western, educated, industrialized, rich, democratic populations. So this is a term from psychology that describes that a lot of the research is actually done with populations that fulfill this kind of weird acronym. But of course, most of the world does not live in these societies. And even within these societies, not everyone is educated. And often the people who are tested in psychology studies are undergraduate students of psychology, which is not most of the people in the world are not undergraduate students of psychology. So that's one of the benefits of testing outside the lab, is that you can test other people. You can also test in parts of the world where there is no laboratory nearby, either because there's no university in this place, or it because it's that's the next point, but because it's too much cost to have a laboratory. And there's also, within even these weird societies, there's people that prefer spaces outside of university, where there's maybe no eye tracker. And heritage speakers of Turkish in Germany, at least to some part, and from my experience in recruiting, are part of this group. So there's a lot of people who don't want to come into this room in the university. They much rather prefer that we go to their homes or we meet them at a cafe and do our study. And then it's also much easier to go with your laptop and your webcam than carry around this whole setup that we saw before, right? Carrying all of this around is much harder than just having your laptop. Okay, so we can work with remote and hard to reach populations. And it's much cheaper to use your webcam, because if you have a laptop already and it has a webcam, that's all you need. So there's no additional cost for webcam-based eye tracking. Whereas we talked about this a little bit before the talk, whereas the other high-end eye trackers are quite expensive. They start from a couple of €1,000 or dollars and range into easily 5 digits, with 20, 30,000 euros possible. So that's very expensive for some laboratories. Another aspect that I like to praise is that I find webcam-based eye tracking, because it's no additional technical setup, it's just your webcam, easier to learn and acquire as a skill. Whereas lab-based eye tracking, because it has a lot of technicalities, requires more training. And this training is not always accessible, also because you need a person that already can do it to teach you, generally. So running webcam-based eye tracking is might be more approachable or easier than lab-based methods. Also because there's a lot of online training and online support available. So that's the reasons why. Then the next question is, how do we do this, right? Because yeah, there's lots of tools that allow us to do it. Essentially, the method behind it is very similar. The webcam tracks the movement of the pupil, And because the pupil is black, it reflects light differently than other parts of the eye. And there's also an algorithm behind it that, after calibration, can calculate where on the screen a person is looking. And in most of the studies that I'm aware of in psycholinguistics, people are using the WebGazer JS, WebGazer JavaScript, which is has the subtitle Democratizing Webcam Eye Tracking on the Browser. It actually comes from, I think, business psychology, but has been adapted in linguistics quite commonly. That's just a tool that is available already. And what happens is that eye tracking coordinates are computed in participants' browsers. And then what you get is not a video or anything like this. You just get coordinates of the location on the screen that they've been looking at a given time. And the tool that I prefer and suggest using, there's a lot of other tools available that are also great that use WebGazer. But let's say the one that I'm most familiar in using and have used in my studies is PC IBEX. So this is representing a P. See IBEX. It's one of several platforms to program and host webcam-based eye tracking experiments and other types of online experiments. It's completely free because it's maintained by the University of Pennsylvania and the linguistics team there. It has a great support group. The people who are maintaining it, but also users, are actively asking questions in the forum and answering questions. There's a detailed documentation and examples and templates for experiments and video instructions. So it's really easy to start with it, I would say. And you can do lots of types of experiments in PC IBEX. For example, surveys, questionnaires, acceptability judgment tasks, rating tasks, Stroop tasks, picture selection tasks, audio recordings. So you can also use the microphone of the phone or the laptop to record audio. You can do eye tracking, lots of experiments that are possible in linguistics on the computer. As I said, there's very good documentation that explains in detail how each kind of experiment can be done. Yeah, so those are the benefits. You can just Google this or look for it later. As I said, there is an active community around it already, but I really like the tool. So if you have questions and want to try it out for yourself, you can just write me and I can send some things or look at your code if some of the things are a bit unclear. But with like anything in the world, there are certain problems that make, of course, when something's free and is a webcam and not a webcam that is designed to be an eye tracker, but just a normal webcam that is designed to allow us to do what we're doing right now, to have meetings. One of the problems that can happen with webcam-based eye tracking is that there are usually delays depending on variation between people's different computers, different webcams, internet speed, etc. But this is something that you can usually find out after the study and then subtract from your data. So you make sure that the delays are removed. But this is something you usually don't have to deal with high-end eye trackers. But it's something to be aware of, that there might be delays in the data. So let's say I'm looking at the letter D right now. There is a possibility that the eye tracker records it 300 milliseconds after my look, which is not a huge problem depending on your design, but it's something to be aware of. The other aspect is accuracy. So what you see here is a calibration screen for, on the left side, a high-end eye tracker, for example, the iLink from SR Research, and on the right-hand side, WebGazer, what I've just been talking about. And the dot is always where what was shown on the screen, and the circle around it is how accurately the eye tracker measured where people were looking. And what you see is that with iLink, it's pretty accurate. It's a few millimeters away from the dot maximum, but generally the eye tracker knows pretty well that people have looked at the dot. With WebGazer, the circle also surrounds, um, so the shading also surrounds the dot, but it's much wider. So if you wanted to do eye tracking during reading, and you had a letter here and a letter here and a letter here, there would be too much overlap and you wouldn't know, or you even had a word here and a word here and a word here. There would be too much overlap and you wouldn't know where the people are looking. So it's not suitable for eye tracking during reading. But what you can do, and what a lot of people have, or few people have done successfully by now, including us, is that you can have, for example, a picture here, a picture here, a picture here, and a picture here. You leave some gap between the pictures, and you can pretty well know which picture the person looked at, just because the screen isn't too full. And that's great for one kind of studies that I will be talking about. Another thing is the sampling rate in online eye tracking. So when you have an eye tracker in the lab, one of those high-end eye trackers, they record a data point consistently, for example, every 8 milliseconds. The online eye tracker will vary a little bit depending on, again, internet speed, people's screen resolution, how much RAM the computer has, so some of these factors. But generally, for the type of studies that we need, it's more than enough. Yeah, people also find it sometimes difficult to calibrate the eye tracker at home, but if you give them good instructions on how to do it, they usually manage. But at the lab, that's not a problem. The calibration almost always works perfectly. At home, there's just some things to be aware of, such as lighting, how close or far from the screen you are, and things like this. So you have to tell your participants to, yeah, make sure that these things are in order. Or what you can do is what I'm usually doing now when I do webcam-based eye tracking is I just take my computer, go to their home or wherever they want to be tested, sit next to them, and I make sure that they have a good distance, there's good lighting, etc. So it's kind of like having the high-end eye tracker moved, but just using the webcam. Yeah, the using webcam-based eye tracking and PCI-based is as easy as just creating an account on the PCI-based farm, and you can create as many accounts as you want, even with the same email address, I think. And you also may have to create many accounts, because if you have many experiments in one account, your account will be full. The storage room will be used, so you might have to create a new account, but that's completely fine. I have like 12 accounts. Okay, doing research with webcam-based eye tracking, or generally with eye tracking. There's two main uses in linguistics. One is in the visual word paradigm, which is what we'll talk about now, but that's usually when you have pictures on the screen. So visual stimuli on the screen, and you have auditory stimuli, sound that you play, sentences that people hear while they look at the screen. And for this, webcam-based eye tracking is usually good enough. And this shows a sort of higher level language processing, such as syntactic parsing, discourse comprehension, inference. On the other hand, we have eye tracking while reading. That's just what it says. You have text on the screen that people read. This usually requires high-end eye trackers. And this shows us usually you would say it's lower level language processing. If you're looking at how they read, how they process words or letters, or how they recognize words, that's a lower level of language processing, sort of the first step. And we'll talk today about visual words paradigm eye tracking. So much for eye tracking. let's look at bilinguals in the sense of the studies that I do. So, for example, I work I am Turkish. I'm a native speaker or a heritage speaker of Turkish as well as German. So I often combine these languages in the studies, also because it offers insights into phenomena that are quite different than German or English because it's from a different language family and has a different topological structure. Um, okay, so I can work with speakers of Turkish in Turkey, which is around 80 million people. I can work with speakers of Turkish in the US, which is somewhere between 300,000 and 1 million people. And speakers of Turkish in Germany, where the numbers are really just estimates, but let's say 3 to 4 million people. And these two groups in the US and Germany, they're often bilingual. So often they speak Turkish and English, or maybe even tri or quadrilingual. So a lot of people also speak Kurdish, other minority languages of Turkey like Arabic or Armenian. Yeah, in Turkey as well as in Germany, this is the case. And this group of people, a subgroup of these bilinguals, is classified as heritage speakers in the literature and in the kind of work that I do. And a heritage speaker, there's multiple ways to define it, but as I often define it, as someone who's born in the US or Germany or any other country that is not Turkey, or has moved there before the age of 4, so as a very young child, and has acquired Turkish at home from birth or any other heritage language. Sometimes the criterion is that they have not received education in the heritage language. Usually I don't have this criterion anymore. And important is that they haven't lived in the environment where the heritage language is spoken as the majority language for more than a year. So with Turkish, they shouldn't have lived in Turkey for many years because then they get more Turkish input, of course. Okay, there's a lot of historical background to it, and I have a fun exercise, but let's just jump to the theoretical criteria around heritage speakers a bit more. So we have more general criteria here that you're born in the society in an environment where the societal language is different than your heritage language, or you've moved there for a certain age. So in the context of Egypt, I think there's also quite a bit of migration from parts of Africa that are more southern than Egypt. And people who live in Egypt learn Arabic but have another language as their home language. This home language we would typically call a heritage language. So it would be interesting to hear about this in the context of Egypt as well. Then, yeah, the other criteria we've sort of already talked about. And what often happens with these languages, at least in the Northern European context that we're in, is that across the lifespan, we see a different kind of trajectory of the language proficiency. So what happens with the majority language in Germany, that's German, is that you start learning it at birth, for example, and it gradually improves. It reaches kind of its peak around adolescence, and it stays up pretty high at an adult level of the language. And this is the same if you start learning German later. Let's say you didn't learn it at home, but you moved to Germany at age 4, or you only started learning German in the nursery or school. Then your curve kind of starts later, but you catch up after a few years and then reach adult proficiency, typical adult proficiency in the language. But what we see with the heritage language is a little bit different. So this is the home language, right? The heritage language is, of course, you speak it at home, so you acquire it from birth. And then when the kids start going into nursery or school, they are exposed more to, in Germany, it's German, to the majority language of the country, or in Egypt, that's Arabic, and less to the home language because they don't see their family all the time anymore. They don't have formal education in the language, and the language proficiency doesn't increase anymore. It often even dips a little bit around childhood, transition to adolescence, and then only picks up again around adolescence with the age of 14, 15, when the children start realizing and identifying that this is part of the identity of the language and acquire it a bit more. It becomes stronger again, but it never quite reaches, in many speakers, typically, the same level as the majority language. So you have these gaps that you see between these languages and their proficiency. There's a lot of criticism about this because this is, of course, a typical model that maybe is true for some speakers, but if you look at the individuals, you see that this changes a lot. So if I were to draw sort of my line for Turkish, it would look similar like this. It would also dip, and then yes, the interest would come, and then I started doing a PhD in Turkish, and it would kind of reach this level, right? So it's possible to kind of change this trajectory on an individual level. So what we understand with bilinguals is that they form a very diverse spectrum. There is sort of on the spectrum of knowing many languages, there's being a monolingual, just knowing one language, just the standard language. I think that's rarely true. For example, for Arabic, everyone is at least multi-dialectal. They usually speak the regional dialect plus Fusha Arabic, right, the standard, and maybe multiple other dialects. And then we become always more and more multilingual, right? You can be late bilingual, so you are all at least bilinguals because you know Arabic and English because you understand me. Then we have heritage speakers, which I just talked about, with simultaneous bilinguals who acquire at least two languages from birth, and even more and more, right? It's very common around the world it's the majority that people know more than two languages from birth or in childhood. And this kind of field of heritage speakers has become its own field, and it's not a massive field, but it's its own subfield in linguistics in the last 20 years, right? So 20 years ago, there were very few studies. This is the number of studies on heritage languages. Ignore the colors for now, they have a different meaning. But the height of the bars just shows us how many articles there are published in the scientific literature. And we see that in recent years, there have been more than 100, or actually hundreds of studies published about heritage languages, whereas 20 years ago, this was a very new term. We have several problems in this field, such as the languages that we study. So if we look at this graph, this shows the most studied heritage languages, the 10 most studied. So if you count here on the left, that's 10 languages. It's from a paper that's actually already published. Let me change this to 2024, sorry. Why not? And what you see here is that, so these are the heritage languages that are studied, and on the right you see the majority language, the context, the country and the context that they were studied in. And you see that English is by far the greatest here, which is because most of the studies are from the United States. And the combination that we have is between Spanish and English. Actually, half the studies that you see here in this whole plot, out of the 500 or something studies, are Spanish in the United States. But there's also Chinese in the United States, or Chinese with English also in the United Kingdom, Korean with English, Arabic, actually also one of the more studied heritage languages, but still studied in a very small context. So for example, studies on Arabic in Germany are very, very few. There's a few now on Syrian Arabic in Germany, but very few. Turkish in Germany is the most studied combination because it's the biggest group, but still compared to the Spanish English kind of dominance, there's a lot more work to do. And do you see that it's a very small selection of languages compared to what would be possible to be done. So that's one thing that we should do more and better in the field, is to look at more languages. I can say a few more things about the field, but I think at this point, what interests us most is moving from these bilinguals now that we're aware of the heritage speakers and see how they process language, right? Which is the promise of this talk. And I plan to present to you 3 studies, but maybe just 2, depending on time. I think we just hit half an hour a few minutes ago. And the 3 studies that I want to talk about are at different levels, different areas of grammar. So if this is a model of grammar with kind of different levels, and we have the very internal core level, the syntactic level, so to say, I have 2 studies to present to you. One is on case marking and one is on grammatical aspect. And then if we go into, so then we have the outside level, right? The dark blue, that's the extra grammatical or discourse level. So language information that isn't connected to grammatical systems very much. For this, I don't present a study today, but we can talk about these as well. I've worked on that. But we have the interface between the core grammar and the extra grammatical level, which, for example, is the syntax discourse interface. And there we have a study on pronoun resolution. That is work in progress that I can also talk about. So let's dig in with the first study on Turkish-German heritage speakers' predictive use of grammatical case. And we used in this study webcam-based as well as in-lab eye tracking to compare these methods. So if you see, this was published in 2023, so right kind of when the pandemic was fading. And to get our head into this, I want you to consider this rabbit, because the rabbit plays a crucial role in the study. Here it's a rabbit with the cabbage, which is for the German version of the study. In the Turkish version, it's a rabbit and a carrot. So this is what participants see in the study. They see, for example, 3 images with a fox, a rabbit, and a carrot. And while they see these images, they hear a sentence. They hear a sentence like this. Maybe there's some Turkish speakers. I've met a few Egyptians who speak Turkish, but usually in Turkey. So I'll read out the Turkish as well. Hızlı tavşanı şuradaki tilki birazdan yiyecek. What the sentence reads is the fast rabbit, this guy, there, the fox will soon eat. You could translate it into English with the passive, but that doesn't capture it that well. Turkish has a bit more flexible word order, but the fast rabbit over there will soon be eaten by the fox. But it's an active sentence in Turkish. And what we expect is that when people hear the fast rabbit and they have an accusative suffix, they know, because of the accusative case marking, that this is an object and a patient, a thematic patient, if you think of the semantic roles. They should know that they now need to find an agent as subject for the sentence, for the continuation of the sentence. So they already know the rabbit is out because it's already mentioned. And they can look now either at the carrot or at the fox as a suitable agent for the sentence as a subject. And carrots are not great agents. They cannot do many things. They're not alive. they're inanimate, but foxes can do things. Foxes are animate and active. And especially they can do things to rabbits. So typically what we expect is when people have heard fast rabbit, that when they hear the word there, they're already looking at the fox before hearing the word fox. And this is what we call predictive processing of case marking. So you hear the case marking, the suffix here, and this tells you, okay, this tells you information about the sentence, that this is the patient and the object of the sentence. And you start looking for the subject. So this sentence is one version where the accusative comes first, the patient first. We also have a version of the sentence where the nominative, the agent, comes first. So now it's fast rabbit, but you see there's no suffix. So this is in the nominative, which means the rabbit is the agent. And in this sentence, now you have to ask, okay, the rabbit is the agent, it's doing something. And it's doing something either to a fox or a carrot. And if you think about this question already, you know semantically, rabbits are more likely to do things to carrots. So you expect people to look at the carrot even before hearing the word carrot. Because the sentence is the fast rabbit will soon eat the carrot over there. So we test this, doing several analyses based on the time windows of the looks of the people, and compare these two conditions, the accusative and the nominative condition. And we test this with the bilingual heritage speakers that I just talked about and monolingual speakers in Turkey, just because that also interests us. And this is something that has been studied before. And what we find on a group level is that monolingual speakers show predictive processing of case marking, the effect that we expect, but heritage speakers do not show predictive processing of case marking as a group. These are the corresponding graphs. So we see looks in the accusative and the nominative condition, the two sentences that we just had. They are given in red and blue. And then at the top, we see the result for the monolinguals, and at the bottom for the heritage speakers. And the time windows here give us the sentence. So this is the first noun phrase. Then there's a small pause of 300 milliseconds. Then we hear the word there. And then we have the second noun phrase. So either fox or rabbit. And what we want to see, what we expect, is that these two lines start diverging before people hear the word. And this is what happens here. So the point of divergence, which is this purple triangle, appears before people hear the word. So they're looking at the fox or the rabbit, depending on the condition, already before hearing the word. And this is also what the heritage speakers do, but they do it only after hearing the word, right? This is when they hear the word, and then they start looking at the corresponding words. So this is crucial at the group level, that heritage speakers don't have this effect. When we looked at individual speakers within the group, I think there were 20 to 30 people, something like this, we actually saw that there were different groups of people. So there were people who actually had the effect and were predicting, and there were people who weren't predicting. And the question is, of course, why do we see this kind of difference? And this can usually be explained by individual differences, individual difference factors, which is something that we focused on more in the second study, which I will be using as the final study. So the third study is kind of for the discussion round if you want. So the second study is again on the grammatical level, comparing perfective and imperfective aspect in Turkish. And I believe Arabic also has grammatical aspect. So you can think about how you would conduct a study in Arabic, and we can also discuss this a little bit. So again, we have a monolingual and a bilingual group, not to compare them, but because we're interested in how each of these groups processes this phenomenon, because there is actually no previous study. And this time we have individual difference factors such as language proficiency. So we did some proficiency tests in Turkish and cognitive skills. So we did some processing tests where people had to match certain numbers to certain symbols, for example, as quickly as possible. And the design of this studies, or what this study comes from, where it comes from, is from a lab in Norway around Sergei Minor and Natalia Mitrofanova, and they did the study in Russian, Spanish, and English before, and now a bunch of other languages. But ultimately, what they have is they have two pictures. One shows an ongoing event. So, for example, grandma was planting the flower, so the event is still happening, and a completed event. So grandma planted the flower. So this is the contrast. Or you can have something like this, where grandpa was ironing the shirt, so he's actively doing it, or grandpa ironed the shirt, it's completed, right? And this is the difference between imperfective and perfective aspect. As I said, I believe Arabic also marks this. And the way this is marked in Turkish is the following. So we have a context sentence that people hear. There was going to be a dinner party this evening, right? This is the context. And then they hear either the perfective or the imperfective sentence. So grandpa, or actually we said the elderly uncle. And we flipped the word order a bit, but basically in the perfective sentence, we have the clean shirt. And then we have the verb iron, which is the crucial critical item here. And it's marked with the past tense, which is also marking the perfective in Turkish. And then we have the uncle. So you see the word order is a bit flipped. We have object, verb, subject, but that's completely fine in Turkish. And then we have the imperfective in contrast, and it's the same sentence, just the verb has a different inflection. Specifically that we have an imperfective, a progressive marker yor, which marks that an event is still ongoing. And then again, we have the past tense. So this is the contrast that we have. And it's, of course, what you expect is when people hear the imperfective, they look at the ongoing event. When they hear the perfective, they look at the completed event. If they have and know the difference between these forms of aspect. Okay, right? So people see these two images, for example, and hear a sentence. And what we see in both groups is that they're very accurate in their responses, over 90% or close to 90%, depending on the group. They choose the correct picture, right? So they hear the sentence and they have to match the sentence to a picture. When they hear was ironing the shirt, they choose this picture. When they hear ironed the shirt, they choose this picture, in the corresponding Turkish version. In the eye tracking data, this looks, this is also what we see, but it's a bit more mixed. So again, we have our two conditions. We have the imperfective and the perfective. And this time we have looks to the target condition. So what you would expect is that basically what you would expect is that in the perfective condition, this red line goes up quite high, and the blue line goes quite down, because this is the imperfective. And the target is, in this case, the perfective picture, so the completed event. This dotted line marks the end of the verb in the sentence. So what actually happens is that between the end of the verb, which is around 500 milliseconds, sorry, it's the start of the verb onset. It's the start of the verb. Between the start of the verb and people looking significantly more to the kind of correct picture, we have like 800 milliseconds or 700 milliseconds. And this happens much faster in the imperfective condition, right? So the correct looks are already significantly higher after 300 milliseconds after they hear the verb. which means the effect is there in both studies, but the imperfective is kind of perceived as stronger, which says something about the nature of the imperfective versus the perfective in Turkish. Because if you look at the perfective here, you see that this marks the past tense and the perfective aspect in one morpheme. But if we look at the imperfective, we have an extra morpheme for the imperfective, and the past tense is marked with another morpheme. So here we have kind of a splitting, which seems to fasten the processing of grammatical aspect. And here, the grammatical aspect indication doesn't seem to be as strong, but it's there. What we learn additionally is that there is an effect of language proficiency. So on the x-axis here, we have time, which is scaled, which is why it looks like -1 to 1, but that's time. So from the start of the sentence to the end of the sentence. And we see that people with higher language proficiency scores, that's the red color, look to the target image earlier and more than people with lower proficiency. That's the green, and the blue is intermediate proficiency. So there's a clear kind of difference in the imperfective. In the perfective, this difference is a bit more mixed, which we can discuss also. But generally, what we see is that individuals' proficiency influences how they process language. So the more proficient they are, the quicker they process. This is for the heritage speakers. And remember, we also had the processing speed effect. And basically, this shows the same. So people with higher processing speed, people who can process anything in general faster, not just language, but as a cognitive skill, have this capacity, show more target looks earlier and in general than people with lower processing speed. So individual differences matter quite a bit here. The last study that I cannot talk about due to time is pronoun resolution in bilingual Turkish-German bilingual children, but we can dive into that if you are interested. And I would like to wrap up with a little bit of a discussion here. And hope to have shown you that eye tracking offers a great window into online language processing. We can really see on a very, very fine-grained level of morphemes even how language is processed on a millisecond scale. We should consider when we work with bilinguals some of the key issues, such as baselines. So do we compare these bilingual groups to other people, which seems like we have done a little bit here, or do we frame it as them having kind of their own effects? We should be aware of individual variation because it matters. And we should lean towards experimental studies to really see how the subconscious processing happens. And all of this hopefully will lead heritage language research and sort of my subfield towards a more inclusive and nuanced perspective on bilingualism to form a holistic understanding of the capacity to acquire, learn two more languages and also to use them. With that, I want to thank you in the languages that most of my research has been so far, which is Greek, Efharistopoli, Teşekkür ederiz, Turkish, and Spasibo for Russian. Yeah, thank you very much.